In this video, we're going to focus on factoring perfect square trinomials. So let's try an example. Let's say if we have the expression x squared plus 6x plus 9. How can we factor this particular expression? What can we do? Well, let's focus on the 9. What two numbers multiply to 9 but add to the middle coefficient 6? 3 times 3 is equal to 9, but 3 plus 3 is equal to 6. So to factor this expression, it's going to be x plus 3 times x plus 3. And you could check it out. You can test it to make sure that this works. To prove it, FOIL the expression x plus 3 times x plus 3. X times x is x squared. X times 3 is 3x. And 3 times x is also 3x. And finally, 3 times 3 is 9. So if you add the two middle terms, 3x plus 3x is 6x. So you get the original expression, x squared plus 6x plus 9. So we know this is the answer. But we can write it as x plus 3 squared, which makes it a perfect square trinomial. So how do we know if a trinomial is a perfect square? Focus on the first coefficient and the constant term. The square root of 1 is 1, and the square root of 9 is 3. If you multiply these two numbers, you're going to get 3. And if that result gives you a number that's, if it's half of the middle term, then it's going to be a perfect square trinomial. Sometimes you might find this formula to be useful. If you have the form a squared plus 2ab plus b squared, then you can factor it by writing this a plus b to the second power. So in our particular example, this is x squared plus 6x, which is really 2 times 3x plus 9, or 9 is the same as 3 squared. And this is equal to x plus 3 squared. Let's try another example. X squared plus 10x plus 25. Let's factor this expression. So, is it a perfect square trinomial? Well, let's find out. The square root of 1 is 1, and the square root of 25 is 5. If we multiply 1 and 5, we're going to get 5. And 5 is half of 10. So that means it's a perfect square trinomial. Now, what two numbers multiply to 25 but add to the middle term 10? 5 times 5 is 25, and 5 plus 5 is 10. So this is going to be x plus 5 times x plus 5, or simply x plus 5 squared. So that's one way in which you can get the answer. But let's use the formula. A squared plus 2ab plus b squared is equal to a plus b squared. So notice that a squared is x squared, and b squared is 25, which means b is 5. So I can write 25 as being 5 squared, plus 2 times a, which is x, and b, which is 5. So as you can see, 2ab is 2x times 5, which is 10x. They're equivalent to each other. So therefore, we know the answer is going to be x, which is a, plus b, or 5, squared. You don't have to use the formula, but you could if you want to. Now what about this one? 4x squared plus 12x plus 9. Is it a perfect square trinomial? Well, let's find the square root of 4 and the square root of 9. The square root of 4 is 3. I mean, not 3. I take that back. It's 2. The square root of 9 is 3. And if we multiply 2 times 3, this is equal to 6, which is half of 12. So that tells us that this is indeed a perfect square trinomial. So we know that a squared is going to be 4x squared, which means a is 2x. And b squared is 9, so b is 3. And we know the answer is going to be a plus b squared. So that means it has to be 2x plus 3 squared. So according to the formula, this is the answer in its factored form. Let's prove it. So because the leading coefficient is not 1, the techniques that we need to use to factor this expression is going to be a little different than the last example. Now the first thing you need to do is multiply 4 and 9. 4 times 9 is 36. Now what two numbers multiply to 36 but add to the middle coefficient 12? This is going to be 6 and 6. 6 times 6 is 36. 6 plus 6 is 12. Now let's replace 12x with 6x and 6x. And then we need to factor by grouping. In the first two terms, take out the GCF, which is 2x. 4x squared divided by 2x is 2x. 6x divided by 2x is 3. Now, the GCF for the last two terms is 3. 6x divided by 3 is 2x. 9 divided by 3 is 3. So we can factor out 2x plus 3. So if we take out 2x plus 3, we're left over with 2x. And if we take it out here, what we have left over is 3. So as you can see, 2x plus 3 times 2x plus 3 is simply 2x plus 3 squared. Now let's try another example. Let's say if we have the expression 9a squared plus 30ab plus 25b squared. Is this expression, is it a perfect square trinomial? Well, let's find out. What is the square root of 9 and the square root of 25? The square root of 9 is 3, and the square root of 25 is 5. And 3 times 5 is 15. And notice that 15 is half of 30, which means that this is indeed a perfect square trinomial. So a squared is going to be equal to the first part of this expression, and that is 9a squared. So a is therefore the square root of 9a squared, which is 3a. B squared is equal to the last part of this trinomial. That's 25 lowercase b squared. So capital B is going to be 5 lowercase b. So we know the answer is going to be a plus b squared. So therefore, the final answer should be 3a plus 5b squared. If it's a perfect square trinomial, this is what you can do to quickly get the answer. So it should be 3a plus 5b squared. But now let's confirm it. So first, we need to multiply the leading coefficient and the last coefficient. 9 times 25 is 225. What two numbers multiply to 225 that add to the middle term 30? 15 times 15 is 225, and 15 plus 15 adds up to 30. So we're going to replace the middle term 30ab with 15ab plus 15ab. Now let's factor by grouping. In the first two terms, take out the GCF. The greatest common factor is 3a. 9a squared divided by 3a is 3a. And 15ab divided by 3a is 5b. Now let's take out the GCF in the last two terms, which is 5b. So 15ab divided by 5b is 3a. 25b squared divided by 5b is 5b. So now let's factor out 3a plus 5b. So if we take out 3a plus 5b in the first expression, or the first term, we have 3a left over. And if we take out 3a plus 5b in the last one, we have 5b left over. So 3a plus 5b times 3a plus 5b is 3a plus 5b squared.